Good afternoon, everyone, and welcome to our final session of Earth Science Week. It's been a great series of programs today, and we're wrapping up our session with our teacher professional development. So hopefully you and your students have been able to attend some of the sessions throughout the day. If you've missed out on anything, we will be sharing the recording, so you will be able to get access to this session and the other ones that have been on. We've been really lucky to be able to host all of these virtual excursions that have been proudly supported and funded by Geoscience Australia and hosted by Virtual Excursions Australia, and of course with the support of Dart Learning, who advertise all our digital programs. So it's going to be a really interesting program this afternoon. We've got our questions that you can put through to the Q&A, and also if a presenter asks you a question, that you can put that into the chat. So firstly, I'm going to hand over to Jo from Geoscience Australia, who's going to be managing and moderating this session today. Thanks, Jo.
Hello, everybody. My name is Jo Fail. I am the Education Centre Coordinator at Geoscience Australia, which is the government's scientific organisation that measures, monitors and better understands our amazing continent Australia and the world more broadly. Now, I first want to just kick things off by acknowledging that I am presenting here from the lands of the Ngunnawal and the Ngambri people, where science has been done for thousands and thousands of years. And I do want to pay my respects to elders past and present. Now, teachers, thank you for joining us this afternoon. Today, what we've organised is a bit of an informational session from some of the major players in earth science education. And I wanted to collect these organisations and these passionate people together to basically showcase what sort of services, what sort of resources are on offer from these organisations, with the ultimate aim of you knowing that if you come to any one of us, you are going to get great support for your students and also for yourselves to bring earth science in a really meaningful way into your classrooms. So joining us in the room today, we have Jo from AusEarthEd, we have Susie from the Core Learning Foundation, we have Phil from TESEP, and we also have Shona from Geoscience Australia, who also happens to be my boss. So I invite all of them to turn on their cameras and give everyone a wave. These good folk dedicate their lives and their passion to bringing some earth science into classrooms, and I think are great resources here. So throughout this presentation, they're all going to take turns to showcase what they can offer you as teachers. But along the way, I definitely encourage you to put any questions in the chat, which we can address as we go or at the end. Now, for those teachers who are joining us online, if you don't mind, please put your location and your the year group of the students that you teach into the chat, just to give us a bit of a reference. But we also note that this is recorded, so any of you watching out there in the future, hopefully there is definitely some relevant information for you as well. So with that in mind, we've got about 10 minutes per organisation with some Q&A at the end. And we're going to kick things off by handing over to Jo from AusEarthEd. Jo, thank you so much for taking the time to join us, spotlighting you, so you're front and centre. Take it away, mate.
Love the front and centre. No, fantastic. Okay, if all things are going well, then all things are working. Tick. Okay, thank you so much to GA and Virtual Excursions Australia today for the opportunity. Thank you so much to all of the teachers that are online now and in the future. We know that your time is crazy precious, so we appreciate you dedicating some time to earth science education. So I will speak quickly, but I'll try and slow myself down a little bit so I'm intelligible. My name's Jo and I'm the CEO of Australian Earth Science Education, or AusEarthEd. If you've known us for a while, you may have known of us as Earth Science Western Australia. And we had the beautiful opportunity a few years back to sort of broaden our name and show that we're sort of covering more than just Western Australia. And we have staff on the ground in other places as well. So I guess the first thing I'd refer people to is our new website. Hopefully it's fairly self-explanatory. We have heaps and heaps of teaching resources in the Foundation to Year 10 Earth and Space Science area, and also year 11 and 12 earth and environmental science. And we've got a growing number of resources that sort of step into the STEM space. We believe passionately that, you know, all of the big earth science problems, challenges and opportunities are very STEM based. And I do not know a single earth scientist or geoscientist that isn't very STEM based as well. So just giving some opportunities for STEM projects to actually include earth science context. So that's sort of where we're at. When you jump into our website, you'll actually be asked to choose your state or territory. And the reason that we ask you for that is then if there's additional services in your area, you've actually got access. It's really clear what you can get sort of where you are. Some of our projects that sort of spin out of this you may have come across are our WASP resources and our PALMS resources, but I would point you to the AusEarthEd website as the central point. We're trying to sort of bring everything into the one location to make things easy for you, because again, you don't have time for hunting around. I guess one of the other things that we're sort of really proud of on the website, we have a lot of materials where we really try to give simple to resource, really cheap and easy to run hands-on activities. Big believers that, you know, the best earth science is hands-on and the best learning is hands-on. But over the last couple of years, we've actually been videoing a lot of those. And apologies, they are kitchen bench backyard videos. That's how our team works. But they really give you an idea of how you might run these in your classroom. We found a number of teachers enjoy previewing them to help them see if they work for their classroom or not. And to be honest, I've gotten a bit lazy and I preview the videos instead of reading the activity outlines. It's quicker, it's easier. So we've got 2 YouTube channels, which you'll find linked to our stuff. The AusEarthEd one is the newer one, and it does have our hands-on videos. The second one we've sort of kept as is because it had a huge subscriber base we didn't want to kill. The Earth Science West Australian one is focused on more of our produced animations. And we have a number of really short, sharp animations. And to be honest, the theory behind the ones we've chosen are where we've wanted to have visuals on some of the biggest misconceptions in earth science. So we've really tried to cherry pick where we wanted to make sure that animations made things clear. Because as we know, a bad scientific diagram is a great way to breed misconceptions. So they're the 2 channels. For your reference, I know that people are from lots of locations now and watching this. We offer a range of services across Australia. We actually have people on the ground in 3 states and territories. So we've got a decent sized team, a couple of people in Western Australia. We have somebody working in the transition to year 6 space in the Northern Territory, and somebody working in the year 11 and 12 space in New South Wales. So that sort of gives you an idea of the kinds of services that are available to you. And we'll keep that updated. And just to give you a sort of high level overview, over the years, we love being in classrooms. We love being out in the field. You know, give us the opportunity to be out and about, and we're really happy to engage. So these are our all-time stats. But last year was certainly one of our biggest years. And I like to highlight that because that's when we really started to work more heavily in the Northern Territory in New South Wales. And we've started to do little bits and pieces in South Australia too, and have really enjoyed doing that in the primary space in South Australia. So I guess that's us in a nutshell. I'm happy to answer any questions, but I won't take up any more of the time.
Alrighty, thank you so much, Jo, for that very succinct overview of AusEarthEd. No immediate questions in the chat, so we will power on, and we're going to hand over to Susie from the Core Learning Foundation. Susie, the spotlight and the stage is yours.
Righto, I will try and share my screen and go for it from there. So hello everyone, I'm coming to you from Whadjuk Balladong country over here in Western Australia, and I'm Susie. I love rocks and I climb volcanoes in my spare time. I'm also a geologist who became a educator, and as a result, over 20 years, have developed what I call the core learning model. So core stands for the Centre of Resource Excellence, and of course, our richest resource are our students. So that also has a double tone in it, that the resources industry is something that needs a student talent pipeline to become aware of what the earth science is all about and how it leads to careers. So I'm very, very passionate about making sure that our students are earth science aware. And I don't know, something's happened. I can't move the thing.
Susie, you've knocked yourself onto mute, unfortunately.
So if you want to fix the earth, you have to understand how it works. And our students have to be aware of, working in this decarbonated world, what needs, what subjects, and where we need to go with it. And we have to create that awareness for them. Because I think what we find is that we have to put earth science back on the map so that the students can understand how interdisciplinary it is and the careers and the diversity of careers that are coming into the future with it. Look, I'm just going to stop sharing and I'm just going to go on and say that I've got the core learning model, and it is basically interdisciplinary based on STEM skills, creating the awareness of how to work in the industry. It is interdisciplinary, and it's making sure that students are aware of potential career pathways and how it relates to them. The whole idea of the core learning model was to create that awareness of where science is going, and to make sure that geosciences is up on the front foot. We're working through about 21 schools in Western Australia at the moment, but through what we call our Gamifying Earth Science initiative, we've created a digital platform where sciences, or in the earth science context, are used to deliver earth science learning, where it's connected to a greater awareness of earth science plus the careers associated with it. We have two platforms. The first platform is a Minecraft. The game is called RRR, Resource Rescue and Respond. It is based on a fictitious mining town where students work in a training facility as emergency response personnel and have to work against preventing disasters or mitigating against disasters for the town and the mine. Our second game, which is called Old as Dirt, features our very strong iron ore industry here, but it takes you across the whole mineral values chain from formation of iron ore through to export. All our games in our learning model are actually cross-curricular and also include the general capabilities. I guess the one thing about our core learning model and our gamifying initiative is that it is a curriculum delivery. It's integrated into the curriculum. It is reportable and accessible. We do what we call project-based learning, but it's not a standalone project. It's actually where we use a STEAM framework to deliver STEM learning. At the base to it all are the STEM skills, both intrapersonal and interpersonal. And I guess having come from industry, I made sure that the way that people work is how the students understand, because the biggest thing is to connect, to get students to understand how their learning connects to themselves and then also to the careers, and have that awareness, because it takes like a relationship of learning for them to actually be familiar with what it's all about, particularly for our metro students who don't have that awareness of what the resources industry actually does in the regional and remote areas. So, so between our learning model, which is what we do is train, mentor and coach. We work with the teachers within the schools, and the Gamifying Earth Science initiative is a part of that, but it is more independent and self-managed. So, there's more information about it, but I think I've sort of got it in a nutshell, and sorry that I stuffed up with my presentation.
No worries, Susie. I've actually put a direct link to the gamification segment of your website into the chat, so teachers can go check that out. I note that there is also a sign up your school button. What happens after you click that button, Susie?
You have a chat and I'll give you the link, and all I want is feedback. But I will also help you along the way of how to implement the games into your class to make it a reportable and accessible tool.
The free product, and
Yeah,
all
they're
you want
both
to do is have a dialogue.
Yeah, all free.
Amazing, amazing. I've actually played some of these games. Susie came to visit us at GA last year, and they are fun and they are educational, so I can vouch for that.
Susie, what's the age group that the games work for best?
Yes, I didn't realise this myself when I created the games, but the games are adaptable to anything between Year 3 and Year 12. Because there's a lot of content that is covered by them. They're very, very deep in content and align with the Australian curriculum as well as with all derivatives of it, depending on the state. So you can use the game to just as a task, a learning task, or to complement existing tasks, or you can actually use the games to develop projects on, and use the games to have extended tasks as well, like building robots to fight bushfires. But if you want more information on that, I can speak to you and show how those games can be adapted to whatever year level you would like.
Amazing. A very personalised approach, it sounds like, Susie. We will, I think, rapidly move on, and the next person in the spotlight is geologist extraordinaire Phil with TESEP. Take it away, mate.
Okay, thank you, Joe. Share my screen. Seconds. Right, how's that? Is that coming up?
Oh, yep, there we go. We've got it. Looks
beautiful. No worries, thank you. Well, thanks very much for the opportunity to talk to everyone, and good afternoon and happy Earth Science Week for 2023. I'm coming to you from Newcastle in New South Wales, so we're on a Wabakal country here, and also just acknowledge our traditional owners and also our first Earth scientists here in Australia. The TESEP, the Teacher of Science Education program, has been around since around 2006. We're supported by the Australian Science Teachers Association, and we have a whole range of partners and sponsors from industry, government, through to academia, Mets and individuals as well. Our team are mainly geoscientists like myself, but have got a lot of experience in outreach and, in my case, tourism as well. And really, I guess we have two roles as we see it. Firstly is to teach the teachers, but also to introduce Earth science to young Australians. And we do that through a series of professional development workshops. We run webinars, we've got field trips, and we've got classroom incursion opportunities. We also make a point of really connecting our teachers and our students that we're visiting to their local geology in the landscape and to Indigenous stories, to just really emphasise and inform people about our connection to land. Like we've seen from Joe, we're pretty cost effective as well with multiplier effects. We have our teachers will pass on their knowledge, and of course one teacher will influence a lot of students as they teach multiple classes. We have a series of workshops, what we call the Challenging Earth series, and you can see the 11 listed there. Critical minerals and the energy transition are pretty popular at the moment, but of course things like the rock cycle, our place in space, and plate tectonics are fundamental in the curriculum, so they run pretty regularly as well. Our resources include a rock kit, so fantastic rock kit with hand specimen size samples. We've distributed around 850 of those nationally now. It's linked to a plate tectonics poster, and we also have a lot of online resources. These include our website, 3D imagery, and photo micrographs. We really encourage hands-on learning, so using the rocks, looking at experiments, activities, observations that we can make, their physical properties, and then linking those rocks back to minerals and their uses in everyday life as well. And we also run a PD workshop introducing people to rocks and how to use them. Just as an example, this is my favorite from the rock kit number 34, it's the basalt with the peridotite. So this is a rock that's come from the mantle and can get to the Earth's surface in places like mid-ocean ridges or even hotspots. You can see the hand sample there, the big olivine cluster. That number links back to the plate tectonics poster, so you can see where these rocks form and where we would find them. We've got 3D imagery from our partners at AusGeo.org, who provide high resolution photos that you can zoom around in, and you can change the angles, change the resolution, etc. So really good for a class when you want to show people something on the screen or let students discover things themselves. And we also have photomicrographs. So these are really thin slivers of rock put on some glass slides, and we've had Macquarie University take photographs of those to look at the optical properties of the different minerals. So all interlinked with our website as well, which provides a description of the rock, where it's from, how old, etc., etc. So I guess our model is that we have schools either purchase or have a partner donate a rock kit to them, and then we will go to a school and we'll present workshops on how to use the rock kit, lots of activities with that, and also choose another one of our workshop topics. The idea that we like to promote is that a school will host teachers and lab techs from neighbouring schools. And then we also have opportunity for classroom incursions and also for field trips, particularly if we can highlight the local geology and take teachers out and show them how to do some basic observations and measurements and geological mapping. Like everyone, I guess we're back on our feet after COVID. In 2022, we had 54 school visits, and you can see they were in New South Wales, Queensland, Victoria, and South Australia. And we also put together some webinar series, so both in long and short form, which proved to be pretty popular. This year, we're getting even further on the ground. So we've been active again in Tasmania and in Western Australia as well as the eastern states and South Australia. And we're running the last of our 4 webinar series in term 4. So that's something I can give you information on. And I guess I've been lucky to run some workshops in Canberra at Geoscience Australia, and I've got another one coming up in December. And just a huge shout out to Shona Joe and the team and the facilities and resources that are available down in Canberra. If your school doesn't go and visit Geoscience Australia as part of the Canberra trip, they really should, to see the resources in the Ed Centre, the minerals and meteorites and the bit of moon in the foyer, but also the opportunity to hear from the experts who work there. I guess we also help the teachers, as well as helping teachers with the transition to the curriculum, we're also trying to address the issue that geoscience is not often taught by geoscientists in schools. So we can provide latest information, facts and figures, which is changing pretty rapidly with critical mineral space particular. Should say practical and fun activities for the classroom. And we also look at the issues that are involved with getting students engaged in geoscience and just breaking down, well, what is geoscience? What do geoscientists do? The fact that geology does underpin everything. And also just looking at that huge range of career opportunities. The STEM disciplines are important, but there's also roles across the human side of things and those relationships, including communication. And often the options and the variety in geoscience as a career isn't really promoted at schools. So that's me. TESEP, we're here to teach the teachers. We're here to introduce Earth science to young Australians, and we're as well as doing our workshops and school visits in capital cities, we're right out across the country, particularly in regional places. And if you'd like more information, then Jill Stevens is our chair. So thank you.
All right, amazing. Thank you, Phil, for that. We are rapidly moving through our presenters, which is great because it means we're going to have extra time for chats at the end. So this is a prompt and a reminder to all of you good folk in the live room that you can put any questions into the Q&A, and we can have a chat about them as a group at the very end. With that in mind, we're going to move on to our very last presenter, who happens to be my boss at Geoscience Australia, Shona, the Manager of Education and Outreach.
All right. Thanks, Joe. Hello, everybody. Thank you for joining us this afternoon. We're really pleased to have been able to facilitate this special gathering of presenters and organisations for our Earth Science Week sort of day with Virtual Excursions Australia. If you don't know Geoscience Australia, then I better give you a little bit of an introduction. We're based in Canberra. Joe and I are in separate rooms here in Canberra inside this big building. There's about 600 people who work for Geoscience Australia across a wide range of activities, which boil down to aspects of Australia's geology and geography at that continental scale, fundamental geology and information that might link to resources, but could also be linking to the resources we don't think about, like groundwater. We've got community safety work like the the Earthquake Alert Centre here, which feeds into the tsunami warning system for Australia. We've got satellite imagery, such as imagery that might be used for understanding surface water, but we also work with groundwater. We work on the marine jurisdiction, mapping the seafloor around the coastline, but all the way down to Antarctica as well. We've got huge improvements going on with the fundamental infrastructure for positioning in Australia. Your GPS, your phone will be able to be very, very accurate down to centimetre level in places where there's mobile reception because of infrastructure that Geoscience Australia is putting into place. And that general aim for an informed continent, and the team that I work with is part of that, an informed population. If you rock up in Canberra and you come in the front entry, you'll come into a sort of mini museum area where we have specimens from the National Mineral and Paleontological Collection on display. There's a piece of moon rock, as Phil just mentioned. And if down on the side there, you can see there's some new displays that have gone in. The very popular wallaby, which seems to distract all our visiting school students. But if they look up, they'll see there's the model ichthyosaur, and this is part of a display about rocks that have shaped the nation, and that will be expanding into the future. On-site visitors will come through to our education centre with lots of brightness and hands-on displays and things to interact with. And this is one of the bread and butter activities for the team that we've been doing for over 20 years. And that's having school groups come in to us to our own site. The groups are often on a Canberra excursion and the Canberra camp, and often that's upper primaries, but we host everything from the middle primaries through to the senior secondaries. All our bookings are through a platform called Book Canberra Excursions now. If you need help, definitely contact us. But if people are thinking of booking, please do, but please book well ahead, because bookings open 2 years ahead because of the difficulties of various itineraries being sorted out for the interstate school groups. So please think ahead, but we'd love to see new visitors to the education centre. There we go. We are also expanding or adapting our offerings as the curriculum is adapting and changing, as we all know, with Australian Curriculum version 9 coming into play, bringing topics like minerals down into year 3, which is a new stimulus. And simply since the shutdowns in 2020, we have developed an online capability. So if you have a class or a school that wants to book in for a dedicated session, we can do that. And also we're part of these sort of larger sessions, particularly with Virtual Excursions Australia and also the Dart Learning occasions like Science Week earlier this year as well. Another strand to our bow is the resources that we have available. And I've got an image here of quite a lot of them are in print. So everything is available digitally, but some of them are available in print. And that in particular includes some of our posters that I'll come back to. But we've got everything's online, web pages, data portals, which are the organisation data portals, and I'll mention them again later. But there's also sediment analysis cards and the Australian timescale bookmarks. Can you see that there? And we have bulk of these. So if you ever want a class set, let us know and we can send those out to you as well. There's teacher comprehensive resources, there's web page content. So lots of things are there. All available through the web pages, which are going to change their look soon, but I can't show it to you yet. The latest poster we've got is about satellite imagery, and you're welcome to let us know if you'd like us to send you 1 or 2 of those, or an actual little poster pack sent out. It's got a half focus on hazards, but it's also got the focus on using true colour and false colour imagery. It's just a very introductory level to thinking about satellite imagery that we use so much of these days. We have an ever-growing suite of videos. Started off again with shutdowns. It's like, well, if we can't have students come to us, we'll pot a little bit of what we'd talk about with students when they came to us, such as the introduction to plate tectonics, like in 2 minutes, which is a crazy thing to do, really. There's a new video that's just been published by our partner team, the collections team, about the Murchison meteorite. We've got a sample of that here, and it's a very special meteorite, but we also have a scientist that works here who saw that meteorite, or part of it, land when he was a child. So he's been reunited with the actual meteorite specimen from the collection, and that's been on a little video that's just been published at the end of last month. Another thing that happened last year was that I ended up in a collaboration with ABC Education, and they were making a series about landscapes and landforms targeted at Year 8 geography. And that was filmed, some of it was filmed down here in Geoscience Australia, and it ended up that they developed 11 separate episodes. They worked very closely with the Victorian Geography Teachers Association as well, and they were very strong on wanting some content there about introducing fieldwork and fieldwork skills. So there's now these videos all available through ABC Education and their web pages, but ABC Education has got a digibook with some supporting extra information with that as well. So we're really pleased to have been able to work on that with them. Also online, we've got some recorded professional learning sessions. So if you're in middle primary, upper primary, there's content there and all sorts of activities and demonstrations that you can tap into whenever you're ready. Same applies for some secondary plate tectonic misconceptions. There's quite a lot of information there. And of course, we've got the plate tectonics shifting down to Year 8 gradually, rather than being in Year 9 with teachers. So different teachers might be having to focus on that. And then coming up later this term, we've got a couple of sessions that are open for registrations. So in the image there, we've got Dom and Tamara, who are also part of the team, and they've been focusing on our data portals and making content there more accessible for teachers, because we've got vast amounts of information out there, but it's difficult. It's thought of as being only the sort of thing that a scientist would go and use, but they've been doing work to do with that earthquakes portal. They've been working on the satellite imagery, and so there's a session later in November about accessing satellite imagery for yourself, seeing how it changes over time and gives us information about the ground surface. And then there's another session that's accessing a different portal that introduces a bit about critical minerals, but also then if you want to access information about from the portal about that, that's there. Now, what this has spawned is a series of little how-to videos that they're filming to provide little snippets to enable people to get into their portals easily and access that data. As Phil mentioned, we've got TESEP coming to run a couple of days on site here in December, and there's a little field trip involved with that as well, if anybody is thinking of heading this way. And it's been mentioned before, but earth science careers, often there's a lot of misconception about earth science careers, but there's just images here just from Geoscience Australia about the variety, from scientists working on earthquake hazard mapping, to laboratory work, to field work, to satellite imagery, to data and storage and curation, to being a drone operator for ground truthing. There's marine surveys. There's a huge variety of work involved in earth sciences. So students that are interested in earth science and interested in our world have many, many potential pathways that they could take. Now, it's not quite out yet, but our current graduate cohort for Earth Science Week are about to release a Google Earth platformed, hosted set of information about individuals, geoscientists of one sort or another, and a place that has meant something in their career and their life development that's led them down the pathway of geoscience. So there's just some snippets on the screen of that, and that should be available very soon. So as we finish up, I just wanted to remind us all that earth science is amazing. I've got just a few images to go with that. And we hear stories sometimes of teachers that are sort of, oh, I've got to teach earth science and I'm just going to squash that into term 4 into 3 weeks. But please don't. be engaging, be enthusiastic, bring along your co-teachers as well, because they're the ones we need to be getting at and say, you have got support out there. All of our organisations can help you in one way or another to really improve and do the best job you can for the earth science education of your students. And just finishing off about us here, we've got the face-to-face for students, we've got the resources available, and there's the professional learnings to sign up for. And if you want to stay in touch with that, just sign up on the website again for our education updates newsletter, which comes out as an email 5, maybe 6 times a year. So thank you, everybody, and I'll hand you back to Joe.
Thank you so much, Shona, and a big also large thank you to the other Joe in the room, Susie and Phil, for dedicating some time this afternoon or middle of the day, WA, to join us here. Teachers in the room today, right here, right now, I do encourage you to put any questions you have for any of us into the chat. That could be about the resources or services that you've seen today, or any more general questions about earth science education that you might have. But what I hope has been demonstrated today is that there is support out there to help and enhance your teaching. And I hope that you have seen that if you come to any one of us, you should be able to find something that's going to support you, be that excursions, resources, field trips, teacher PD, gamified learning videos, whatever it might be, you can find it with us. This is one part of the earth science education ecosystem. There are others out there, of course, and we do also want to acknowledge that, yeah, there is heaps out there as well, but we are just a small but also passionate subsect of that that is definitely focused on Australian earth sciences as well. I gave everyone the brief of being brief, and they have, and we are ahead of time, which is like amazing. So well done to all of my panelists, which is going to leave us a little bit of time for questions if they do come through in the chat. But while our teachers might be thinking, I might prompt or throw something out there for us to discuss. It's a big one, and I know all of us are passionate and have sat in many meetings and webinars about this, but why is earth science education critically important? Does any passionate panelists want to kick us off with that?
Pick all of us. I think
Joe,
I got
you're
in
first.
because Susie's on mute. Sorry, Susie. Gotcha. I will start. I think apart from the fact that we need so many earth scientists across more industries than you could possibly imagine going into the future, I also think that an informed public is super important. So sometimes we can, and I think all science teachers will agree with this, we can get really laser focused on students going into a very particular career, forgetting that if our students have a fantastic grounding in a wide variety of things, they become educated, they become interested, and there's more options for them in life. So I passionately believe that we should have all students engaged in geoscience or earth sciences, and I am yet to find a student that isn't excited once you actually present it in a really relevant, hands-on, engaging way. And then hopefully, yes, that translates to all the people we can possibly need in the geosciences for all the big, tough problems we have and opportunities we have coming into our future.
Susie, you've always got a contribution for this question, so take it away.
We live on a rock, and from that rock we get water, metal, energy, and that rock weathers to provide an important component of soil on which we get biota. So everything we need is a resource from a rock. And I think there has to be a greater appreciation and understanding of those resources, how they're formed within that rock, and how we as humans use them to sustain our daily lives and our civilizations. So to not have an understanding and an appreciation of what is around us, and that everything from the chair to the light up above us comes from rock, and that rock has to be managed sustainably through a mining and production process, or not even before that, from prospect to export, so to speak, in the mineral value chain. There has to be that awareness. And if we're talking about the shortage of geoscientists, mining engineers, metallurgists, any of those that work in the resources sector, if there isn't that awareness from a very young age in the primary system, that the importance of the rock, therefore the importance of those careers associated with what we need for decarbonisation and diversification and digitisation in the energy economy, well, when, we're not going to get that talent pipeline come through. And I've been through a number of situations, I guess Phil has too, in where we're always screaming out for geoscientists and earth scientists, and we're still not solving the problem. We need to change the curriculum.
It does start with all you wonderfully passionate teachers out there. We do appreciate that you put all that massive effort into bringing earth science into your classroom. And again, yeah, we're here to support in any shape or form. We are an email away from any one of you. So please do reach out. If Phil or Shona wanted to contribute to that question at all, they most certainly can. Otherwise, we do have one lined up.
I'd just add to what we just said from Joe and Susie, that it's our home. Like, why wouldn't we want to know more about it? What's happened to it in the past? What we think is going to happen to it in the future? But just the wonder and the awe of geological processes, from volcanoes to glaciers to tides to and then, well, that's just on Earth. Then we get to the planets and space. So I think they're all good reasons to get into earth sciences.
I can hear that passion exuding out of you, Phil. And that's the case for all of us. We love this stuff. So yeah, again, we're here to support. Benny in the chat has provided a question. They would like to be able to incorporate more First Nations content into the earth science planning. Can we, as a group, think of any Dreamtime stories, resources, or concepts that can add and support some classroom teachers? Phil,
are you into asteroid impacts? Is she into asteroid impacts?
Well, it's on the cards to discuss right now. So yeah, Susie, you started. Let's go.
It's one of my favourite ones. It's actually the Indigenous people of New Zealand as well. There was an asteroid impact off New Zealand and the south coast of Australia, and it was witnessed only about 200-300 years ago. And I really love geomythology. And so by the word of mouth Dreamtime stories, scientists have gone out recently to prove these. And they've actually found the tsunami impact wave on the south coast of Australia that demonstrates through the sediment profile, that demonstrates that sighting by both the Māori and the southern Aboriginal people of Australia was actually real. I think it happened in the 1700s. So look, there's a whole lot of geomythology stories, including the sea level rise after the last glaciation event on the east coast, as well here on the west coast, where Dreamtime stories actually demonstrate how the waters encroached and the reef started to form off the Great Barrier Reef. So that's just to name a few. Others want to include some?
Yeah, I think the couple that come to mind straight away is just the observation of the stars, so the emu in the sky and hunting seasons, for example, but also just the use of resources. So here in a Wabikal country, the Wabikal people are the only people in Australia documented to use coal for warmth and cooking, and we know that they traded that along with some of the stone tools as the Aboriginal people would have elsewhere. But there's these long and well-established trade routes as well, and just ingenuity in terms of fish traps. I know there's some in WA, we've got some here in New South Wales and Warorina, and also just the use of the geothermal conditions down around Mount Gambier. So there's and the volcanism down there. So yeah, plenty of examples and resources.
I would add difficult, and I think you probably picked up from our favourite stories already, because I'm a big fan of a number hole, because we basically almost stumble into them all the time in WA and wonder what they are, or some people do. I think, you know, one of the best things that we've stumbled across and are trying to grow is relationships with local Aboriginal language centres, and quite often those language centres are really great wealths of knowledge as well. So if you're looking for local area stories, which are most relevant and up to date, sometimes your local language centre people are also aware of fantastic stories, and you can just have a bit of a yarn and find out some really cool stuff. That's when I really first started to delve into some of the cool fish trap stories of Kalgoorlie, was from that local language centre. The other one, less local, more widely, I'll put a plug in. CSIRO's actually doing some additional work with their Living STEM program, which is Indigenous knowledge into the classroom. And I do know the lovely Dave, who's heading a heap of that work up in WA, is a growing earth science convert. He can't help it. We pin him down whenever we can get him and convert him. So they are looking to certainly include a fair amount of earth science content into their revised materials, and they'll be widely available as they come through. So that's another good one to keep an eye on.
And Jo, I would say you've got quite a lot of Indigenous content already in a lot of your publications that are just all online already, haven't you? Probably
yes, we do.
The most of anybody I know already.
We tried to get things that were quite common across, so that the concept of number holes gets picked up in one way, shape or form. Some of your stone use for tools, there might be like contextual differences, but generally they're a thing. And then now we're going down the rabbit hole, but very fun one, of what are some of the really cool local context stories. So we have, it's not hidden, but it's not upfront on our pages. We actually have a little section on our website just for the Kalgoorlie region, and that has some local language videos and some of that local context stuff starting to come in.
I'll add from a Canberra perspective, which I'm sure is applicable to everywhere else across this country, is that there are obviously local Aboriginal organisations and guides that you can approach to help with your classes, and they can bring their place-based knowledge to your students and provide that really relevant information straight from the source. So in Canberra, there's Thunderstone Aboriginal Services as one example, and I'm sure wherever you are across this great nation, you will be able to find a similar one that can support you with programming.
Yeah, well, in our programs, we always have the Aboriginal aspect developed into our PBLs, what we call PBLs, the noun, the project, and it has been very important since about 2014-15 to give that context, particularly when you're working in regional and remote areas. In fact, I've learnt a lot from First Nations children when I take them on the field trips. To me, the fascinating things was the water trees, and how they manage the water trees and to save water as they migrated across the desert. So that was from the Nudgel children out at Norseman. So it's very fascinating to actually learn from the kids as well.
Amazing. We've had another question in the chat around sourcing fieldwork equipment. And this specific question is talking about water testing kits, but maybe I'll put it to the panel, like where could teachers source basic fieldwork equipment to support their learning?
I'll go the cheap option because we tend to try and find. So you can buy all the very expensive probes that need updating all the time, et cetera, et cetera. Or I know we've actually discovered a lot of, pH testing and your local pool shop or the pool section of Bunnings, the strips from there, even the moisture meters that have become super popular with everyone being obsessed with indoor plants at the moment. How fantastic now we can get cheap ones for classroom use. So yeah, things like your Bunnings and your Kmart's, etc., but particularly Bunnings in this respect. I think we've even managed to get nets as well from pool shops and from the local Bunnings. Quite often finding things that weren't for that purpose originally, but purpose adjacent has been the really nice, cheap, robust way, and it makes them easier to replace because it's easy to just pop down or order online extras.
Yes, I concur with Joe. Over running thousands of field trips with kids from everywhere, having the fandangled stuff, the phone is good. The mobile phone is very good as a piece of equipment, because it's also, there's a number of apps that can do measurement on there and of various bits and bobs, whether it's measuring your barometric pressure or what have you. But I have found that the more complicated the equipment, the more it takes away from the actual experience. And so get those basic things like the pH and the soil testing kit and all that sort of stuff. I even took out the microscopes, and you just don't get round to doing it. It's better just to get down to the basic stuff of taking your notes, taking photos, interpreting what you see, and then take samples home maybe and do it back in the classroom then.
And Shona, we have a love in our little science centre of magnification. You want to talk about that?
I was thinking that the kids, when they come in here, the fascination was still looking at things, be it on a little digital magnifier, which the latest version, they're getting cheaper. Just a plug-in USB magnifier from Amazon was not much more than $50, and we started off over $100, so they seem to be getting cheaper. They don't always last forever, but that really good magnification on the screen. But real microscopes they still absolutely love, but also hand lenses, be they plastic ones or be they proper little lenses, to use. The idea that you have a lens on a lanyard, I think you've done this, Joe, haven't you, out on the field work, or be it in the classroom, and teaching them how to use that properly. We're bringing the specimen up to the face rather than the other way around and the lens going down. So yeah, magnification never seems to fail for keeping the kids engaged, particularly the primaries, but I don't think we should ignore that in the secondaries either. I don't think we've fully answered the particular question about water testing replaceables, and I don't know that I have an answer for that offhand.
Maybe shoot us an email and we can maybe ask one of our lab techs and see if we can get you some more detailed information. But yeah, email us.
I'll just add something to that as well. And they are certainly ones that do have consumables, but Modern Teaching Aids, which is certainly a company that does a lot of educational supplies, they do educational school kits with multiple sets of things for a classroom. So you might find that that's a good one as well. So Modern Teaching Aids, they also do small rock kits, soil kits, and those kinds of things. So you can get quite a lot of that kind of material from the education suppliers as well. And they tend to be a little bit cheaper than some of the scientific suppliers because they're more for classroom use.
Yep, agreed. I think sometimes the testing strips and Bunnings or the pool shop are cheaper, but just as a heads up. We're definitely not for profit. Can I also say their rock kits are lovely, but the TESEP ones are better because they're big, they're hand size. But this is a rock, not that.
Yes, I completely agree with the sizes are sometimes very underwhelming.
Yes.
So sometimes I even suggest get the kids to go out and bring rocks in and then find examples of what the kids have collected to be able to use.
Agreed, but try and line up a geo to check them for safety reasons, please.
Of course.
Yep.
And Phil, the rock kits, they're available through, is it Ward?
Through Haynes.
Haynes.
Yeah. I think it's currently around $420 for a rock kit, tectonics poster combination. But if you get in touch with us, we can try and see if we can get one of our partners to sponsor a rock kit for a school.
Amazing. Look at us all cross-promoting each other. I reckon we're sort of rapidly coming towards a close here. We don't have any more questions in the chat, but I might leave with one final question to each and every one of you, and we'll sort of whip around and everyone have a say. But thinking about your own education, does anything stand out from your own education that you can sort of pinpoint to say, yeah, that's what prompted me into science or geoscience more specifically? And maybe can we emulate that in the classroom?
Where do you?
I used to go on holiday to Scotland as a child, and I had no idea that I would ever end up in geology, but there was these beautiful pieces of shiny schist that you could skim on the lochs and that sort of thing, and hence the rock collection. But I was one of those people that ended up with no earth science in school, so followed a geography path and then diverted when it became clear that that was what was available, that the bits of geography that I loved were actually earth science. So following that path, I think, yeah, what's the emulation thing? It's it's having something to actually have in your hand, most definitely.
I guess I was lucky to grow up on the volcanic plains of Western Victoria, where I had basalts with zeoliths in it. So I had this little creek in my backyard, so that ran over basalts. And so from the age of 4, I played in that. And by the age of 8, I knew I wanted to be a geologist. And I was fortunate enough in high school to be able to do earth science in year 11 and 12 back in Victoria. But my path was set by grade 3. Yeah, there was nothing stopping me from being a geologist.
Beautiful. All right, we're going to throw to Phil.
Yeah, thanks, Joe. So I don't think there was any one moment for me. We were always going away to national parks, walking, looking at different things. My parents were right into understanding where rivers started and flowed, so it gave me a real sort of flavour for understanding that, but also, yeah, collecting fossils just in my neighbourhood. But to be honest, it wasn't until I failed maths at first year uni that I picked up geology and realised, well, where's this been all my life? Because it wasn't offered at school. I was probably going to look to do something in biogeochemistry, and then suddenly, because of a failure, I found geology and found the thing that I was always interested in. And I think now, if I'd had that exposure when I was at school, it would have saved failing maths and a HEC stat. So,
I love it. This is why I'm so passionate about what I do, the accidental geologist, because I am similar, but in that I actually probably didn't connect the dots until I was an adult. So I love science. I actually, in hindsight, love geography. Didn't have exposure to earth science at school. Went into sciences, passionate teacher, biology teacher in year 11 and 12, made me land in biology. Wasn't the right place for me, but you can never underestimate the power of a passionate teacher. But it wasn't until I moved into teaching and started teaching earth science and learning it rapidly and learning from wonderful people like Susie that I had my aha moment. So I was well and truly into adulthood where the dots connected for me, and I've been lucky to do additional work and retrain. I don't regret the pathway, but I do believe passionately that exposure to earth science as young as possible and sustained engagement is absolutely key. No more accidental geologists, please.
All righty, thank you everyone for sharing. We're almost at the hour mark, so we might actually just wrap up there. But I do want to reiterate the premise that I put towards everyone at the start, that if you do need support in the classroom, coming to any one of us, you are very, very likely to find something that's going to enhance your teaching. Phil, there's a hand.
Only because there's a comment in the chat from Mark. It might be worth going to.
Oh, sorry, Mark. Is there any support for programming for the New South Wales syllabus? As a beginner teacher, I have struggled with finding interesting and engaging resources. So New South Wales syllabus specifically.
I've just flicked my email address out to Mark, and you can grab that from the contact details as well. Year 11 and 12, absolutely, we have things, but I can certainly tap our New South Wales person on the shoulder, because it wasn't long ago that she was teaching lower secondary as well. Yeah.
Alrighty, amazing. So Karen from Virtual Excursions Australia will email out the recording of this along with all of our various emails and web addresses. So I do definitely encourage you to have a peruse of what's on offer from all of us, AusEarthEd, TESEP, Core Learning Foundation and the Geoscience Australia Education and Outreach team. A very big thank you for dedicating an hour of your lives to spend with us on a Wednesday afternoon. So thank you for that. And with that, I'm going to hand back to Karen.
Excellent. Thank you, everyone, for your questions as well and for participating, and our wonderful presenters and your wealth of knowledge and the passion. And it's something that Joe and I have spoken about throughout a lot of our sessions today. It's that passion of when you're young, and what you love now can certainly be the thing that takes you into your career. As we can see, our amazing presenters have had that passion throughout their whole lives. So if you love it now, you will love it later, and make sure you just continue your learning and exploring, and just encourage that in your students. When you see your students with that spark, you are going to be those passionate teachers that can get that moving forward for them, for their future lives. So thank you, everyone, for joining us today, and for Geoscience Australia for supporting Earth Science Week programs today. It's been an amazing day. I think we all need a little bit of a rest. It's been fabulous, and we will be sharing all the recordings and those extra resources either later on this evening, or you'll receive them in tomorrow morning. So thank you, everyone, for participating today.